Hello, AP Environmental Scientist. Miss Maycutt here from Ballard High School to go over personal progress check number 6, focusing on EK's 9.4, which is increases in the greenhouse gases, 9.6, ocean warming, and 9.7, ocean acidification. The main terms and concepts we're going to focus on are sea level rise, some disease vectors, learning what those are, ocean acidification, pH, and carbonic acid. And lastly, understanding some ocean biology and species interactions. We're going to focus on questions 6, 7, and 8 first. These gave folks the most trouble, and then we'll wrap up the rest of the questions. So number 6, which of the following changes are linked to an increase in ocean water temperatures? So here we're really focused on increase in the water temperatures, and something to note, as temperatures increase, metabolism increases. So that's one of the core things you need to know. As temperature increases, metabolism increases. So think about in hibernation, right? When it's cold, metabolism decreases. That's how I remember it. And the other main thing you need to remember that as temperatures increase, dissolved oxygen in the water decreases. And we learned that also in our water unit earlier. And my way to remember that is in our rich, cold feeding grounds of Alaska, right? It's cold water, rich in nutrients, rich in dissolved oxygen. All right, so now let's look at our questions. So here we have an increase in metabolism and a decrease in dissolved oxygen when the water temperatures are increasing. That is our answer right there. The rest of them, you just got to watch the ups and the downs. So here we have a decrease in metabolism with a decrease in dissolved oxygen. Next, we have an increase in metabolism, which is correct, but an increase in dissolved oxygen, nope. Lastly, decrease in metabolism and increase, so that one's double wrong. There you go. Number 7, here we're looking which of the following best identifies the primary cause of increasing acidity in the ocean. Okay, so for here, we need to think about acidity. How do we make the oceans acidic? And this is by atmospheric carbon dioxide being absorbed by the ocean to form carbonic acid. So we're really focused on those carbon dioxide emissions. So that's answer number D. Number A, we're looking at microplastics. We know they're toxic and they accumulate toxins, but it's not acidic. Agriculture, that results in eutrophication. Petroleum, that's toxic and kills wildlife, but it's, again, not acidification. Number 8, this was one of the trickiest ones that gave most people trouble. And it's the same concept, talking about ocean acidification, how that might harm coral reefs. All right, now this is different than coral bleaching. All right, so how does acidification specifically affect coral reefs? And it affects all organisms that form calciferous shells. So acidification impacting coral reefs, we have an acid compound that gives up hydrogen ions in water. And the way that impacts biological organisms, especially corals, including corals, is we get that carbonic acid from the carbon dioxide, and that means it has more hydrogen ions. That is a problem because carbonate, which is negative, a carbonate ion, is used to form all those shells, and it's used to form the limestone of coral. So if we have less carbonate ions available in the water for them to form their shells or form their limestone, their structures, then there's going to be less coral. So looking at the rest of these answers, right, so here's our hydrogen ions connecting with the bicarbonate, taking it away from our species. Let's look at phosphorus. Nope. Phosphorus is not a result of acidification. What about attracting invasives? It may change the ecosystem, but it's not directly linked to acidification. What about if we have increase in rates of primary productivity, right? No, that's photosynthesis, and it actually consumes carbon dioxide. So we're looking at D, right? Decrease in the amount of carbonate ions and decline the formation of reef infrastructure. Okay, those were the big toughies. Now we're going to go over the remaining questions a little bit more quickly. Take a deep breath. And here we go. Question number 1. here we're looking at the map and which areas in the United States have the greatest sea level rise. So you're really looking at up the tallest upward arrows. Most of you got this. We see them here in the Gulf of Mexico, all along the East Coast, so the Northeast and Gulf of Mexico. Next question, same graph. Based on the information, which is a likely consequence for the human population if sea levels continue to rise. And you had to look at the questions here. We had inland wetlands increasing from sea level rise. And then wetlands take a lot, they get messed up because of all the storms that are happening. What about coastal areas will experience a decrease of erosion and water pollution? Now that's also going to increase. How about more water vapor resulting in respiratory and cardiovascular illness? Not so much. We really are focused on flood-prone regions along the coast are going to be, we're going to have more property at risk. So this is the human impact on people, because that's what we were looking for. Next one, looking at the data in this diagram, which of the following best supports the claim that the change in duration of warm seasons would result in a higher prevalence of vector-borne diseases? Okay, so look at what we've got, right? Vector-borne diseases, that's these guys, right? The little mosquitoes, and we're saying there's an increased duration of warm seasons, right? Increased duration of warm seasons, okay. Well, we've got melting, which is going to eliminate vector food source, not so much. How about shorter warm seasons? No, we're saying they're longer. There's more of them, so that doesn't fly. This last one, climate change has led to a decrease in vectors predators. There's nothing in what we were given to imply that. We're really looking at increased temperatures and expanding their breeding range. Next, so number 4. Surface temperatures in the Caribbean have increased over the past 40 years. What's the most likely cause? Well, we're definitely talking about, we're talking about increases in carbon dioxide, but the one that gave people trouble was El Nino events. And the thing to remember about El Nino and La Nina is both of them are cyclical. So we're not going to get long-term sea surface temperature changes from these particular phenomenon. So we're talking about carbon dioxide or other greenhouse gases trapping heat near the Earth's surface. Most of you identified it wasn't invasive species or sea salinity. Number 5, what best describes the effect of global temperatures on coral? All right, so again, we're back to the coral ecosystems. So increasing global temperatures on the coral, we're going to warm water will have higher dissolved oxygen. We already discussed the warm water is going to have less dissolved oxygen. So we know that's incorrect. How about, and the rest of these are all talking about the algae relationships. All right, so here's something to know about coral, right? Coral has a relationship with the algae that is forming a symbiotic relationship and gives all those colors. And so it connects with the coral polyp. And if we have warming temperatures, then the algae leaves, and that's what results in the bleaching. When the algae leaves, the coral polyp is still there, but it's at risk of starvation, right? Because it doesn't have that symbiotic relationship with the algae. So our answer here is C, algae that lives symbiotically with the coral leaves the reefs, causing coral bleaching. All right, last question, last but not least, which of the following best explains a cause of increasing ocean acidification? All right, we're going back to that sources of carbon dioxide so we can get that carbonic acid, and that would mean we're not looking at mercury or sulfur dioxide. We're looking for fossil fuels, carbon dioxide, decreasing pH. Remember, acidic is decreasing pH. Uranium and radioactivity levels, not carbonic acid, deforestation, and sea level rise. Again, not acidification. Well, that's a wrap. Thanks for your time. I hope you found this helpful. Talk to your teachers if you have any questions. And just to recap, we are looking at EK's 9.4, increases of greenhouse gases, 9.6, ocean warming, and 9.7, ocean acidification. Your main terms and concepts were sea level rise, looking at those disease vectors, ocean acidification, pH, and carbonic acid, as well as ocean biology and ocean temperatures. Thanks so much and have a great day.